Planet Earth holds a large and mostly unexplored mass, the ocean. While we may not think about the ocean every day, it's a key component in life on Earth, even on dry land. The ocean regulates weather, drives the water cycle, and provides the majority of oxygen, more than half of what we breathe. It absorbs excess carbon dioxide and stores more than 90% of the heat generated by global warming. Ocean life is essential for sustaining the planet's ecological equilibrium. Phytoplankton, microscopic marine plants, play a critical role in this balance. These tiny organisms photosynthesize on a massive scale, converting over 30 billion metric tons of carbon into oxygen annually. Ocean currents, meanwhile, transport warm and cold water across the planet, driving rainfall patterns, droughts, hurricanes, and even seasonal changes. The ocean holds more answers to global climate change than we realize. Despite all this, we know surprisingly little about the deep ocean. The majority of life and terrain beneath the waves remains unexplored. Scientists estimate that more than 90% of the ocean is still unmapped, unobserved, and unknown, especially the deeper regions. Thousands of meters down, the ocean is pitch black and the pressure is crushing, rising by 1 atmosphere or 14.7 pounds per square inch every 10 meters. These extreme conditions make deep-sea exploration one of the most technically demanding challenges in science today. Sending humans or sensors into this environment safely requires specialized equipment and a deep understanding of both engineering and marine science. Exploring Our Deep World, a non-profit organization, is bridging that gap, giving science access to the deep, using technology and human expertise to reach the most remote and hard-to-access parts of the ocean. The health of the planet is highly dependent and directly linked to the health of the ocean. Protecting the land requires understanding the oceans. In 2025, Exploring Our Deep World partnered with Pisces VI, a deep-sea human-occupied submersible. Designed for scientific exploration, Pisces VI can reach depths of 2,200 meters, allowing researchers to reach the barely studied ecosystems in the depths of the ocean. Its capabilities open up access to the ecosystems of hydrothermal vents and seamounts, keys to understanding our planet and gaining insight into the origins of life and Earth's hidden biodiversity. Originally constructed in the 1970s, it is one of the last remaining of its line. Pisces VI was redesigned by Scott Waters over a 5-year period. Its modular design allows for fast deployment and adaptability, making frequent missions feasible in many locations around the world. This versatility helps provide an important role in advancing deep ocean exploration. In June 2025, Exploring Our Deep World kicked off this partnership with Pisces VI, along with Tenerife Research, to launch their first deep-sea mission off the coast of Tenerife in the Canary Islands. This region is rich in marine biodiversity and is home to several unique species of sharks and whales. It's also home to a number of rarely observed deep-sea sharks.
Well, the expedition is taking place in Radaful right now, which is one of the main villages in the, let's say, southeast. And yeah, it's been chosen first of all by logistic possibilities, so the submarine can go close to the test itself, and also by the geography of the area, because it has like a really steep slope and it's facing the channel between Tenerife Island and Gran Canaria Island.
The primary goal on this expedition was to begin tracking the migration and behavior of these sharks, and to lay the groundwork for long-term monitoring in the region.
So yeah, we know that some of the species, the target species, are in danger, as the angel sharks, or maybe the thresher sharks, or blue sharks if it appears, but we don't have enough data of some kind of deep shark species. That's why we're trying to figure it out, if they need special protection or to become an dangerous species, because we don't see it normally, and that's a key thing about this expedition.
Over the course of 2 weeks, the team completed multiple dives at depths of several hundred meters. They used techniques like chumming and baiting to attract sharks to their submersible and observation stations. A few of these dives were dedicated to baiting. The team would secure containers filled with bait onto Pisces and then descend to the sea floor. Once in position, they remained there for extended periods of time, monitoring the surroundings and watching closely for any signs of approaching sharks.
I'm pretty sure that they haven't seen a submarine ever in their life, so we don't know how they're gonna interact with them. We know that in all the previous submarines that have had encounters with sharks, they would normally surround the bait, and after that they will interact and stop eating them. But it really depends on the species, the number of individuals in the moment, and how they will be. There are different personalities even in sharks.
The submarine is launched from the docks at Radazal Marina, carefully lowered into the water and checked by the team before heading out. Once everything is confirmed, it begins its journey toward the designated dive site. A support diver rides on top of the sub during this surface transit, keeping a close eye on its exterior systems and assisting with final checks, ensuring everything is functioning as expected before the sub begins its dive. Following close behind is the support vessel, maintaining constant communication with the sub. The crew monitors navigation systems, checks environmental readings, and prepares for descent. As the sub slips beneath the surface, the support vessel maintains a steady connection, ensuring the team can respond quickly to any changes or challenges. Coordination between the two crews is key, allowing the mission to proceed safely and efficiently. Leaving the surface behind as it enters deeper water and begins the scientific work planned for the dive.
Our dive today have this goal to find out these deep sharks that we can't see with scuba diving methods, because we know that more or less here in the Canaries we have more than 80 species of sharks, rays and mantas, and more or less like 20 lives under the 200 meters deep barrier. We take this dive trip with the Pisces VI, and we try to find out, to describe the behavior, to identify the species.
We are trying to make new studies with the visual sensors too, and this data will help us to provide more ecological, maybe behavior and dynamics, and knowledge about the species itself.
Within this region, Pisces VI has placed transceivers at 250 meters depth to know when a shark with a tracker moves within the vicinity. These devices are crucial for tracking shark movement patterns over time, especially in regions where direct observation is rare. The Canary Islands are home to two particularly important species, the angel shark and several types of deep-water thresher sharks. Thresher sharks are easily recognized by their extremely long upper tail fin, which can be as long as the rest of their body. They use it like a whip to stun schools of fish before eating them, one of the only sharks known to hunt this way. Threshers can be found both in coastal waters and open ocean. Although they can dive as deep as 600 meters or more, They sometimes come closer to the surface at night. Angel sharks have flat and wide bodies with wing-like pectoral fins, making them look like rays. Despite their name, they're stealthy predators, living mostly in coastal and continental shelf waters. They prefer soft, sandy or muddy seabeds where they can easily hide and wait to ambush their prey. They are usually found at depths ranging from 20 to 150 meters.
And nowadays, sharks have been overfished. We have the degradation of the habitats and the trading and the fishing, the targeting, trading and fishing of the shark for the shark meat and the shark fin soup. So that would be the main branches of the threats of the sharks: overfishing and habitats and the trading of the sharks.
They're wildlife, and we have to understand that in a world with increasing fishing pressure, with increasing climate change and global warming, the patterns of wildlife that may be here may change at some point. So the chance of having no sightings during a dive, it can be zero many times.
Why do these shark species matter? Sharks are ecosystem regulators. They help maintain balance in marine environments by controlling populations of prey species. Remove the sharks, and everything shifts. That one imbalance can ripple through an entire ecosystem, eventually affecting coastal health, biodiversity, and even local economies.
Normally, sharks are mesophotic predators, which are in the middle of the trophic chain, or apex predators, which are basically like the white shark, the tiger shark, the bull shark, these ones that will regulate the trophic chain from the top to the bottom. So they are very important, but 2/3 of all the shark species, well, more than 500 species, length less than 1 meter. So we have a lot of small sharks that are really important too, despite they are not the biggest ones and the most famous, but everything will regulate it. If we don't have, for example, this level of the chain, we could have a trophic cascade or waterfall that is basically like a domino effect. So if you remove one of these chains, the ecosystem could collapse.
Another key component of the mission was environmental DNA sampling, a technique used to detect the presence of organisms by analyzing genetic material found in environmental samples like water, soil, or sediment. It is an important step in understanding the ecosystem and where sharks are living within at different layers of the water column.
Sharks are amazing predators, and they have been made for it for millions of years. They are very important. Normally they are very scared of humans. They don't interact with them, and sometimes you are in the wrong situation in the wrong time, but it doesn't mean that sharks are bad for people.
Study them and try to preserve them. So through my work, I would love people to understand how important these beings are for a balance, that we are not that far away from them. It's something that is close to us all the time. It doesn't mean a shark is close to you, but its importance, it's close to you in some way. Is if you consume fish, if you go to the ocean, you want it to be balanced, you want it to be healthy, and that's what sharks do.
Our work in the Canary Islands is only the beginning. As ocean research technologies become more accessible, Exploring Our Deep World is working to support the access to ROVs, remotely operated vehicles, and HOVs, human-operated vehicles. But these efforts are only in their infancy. Thorough research needs to be done, and we need to increase our efforts significantly. Ocean research is quickly maturing as the technology is making the research more and more practical each day. This evolution is key to us understanding the world below the surface. To support this, we must invest in expanding the physical infrastructure of underwater exploration, developing permanent subsea observatories, building modular underwater laboratories where scientists can live and work for extended periods, and deploying networks of sensors to monitor ecosystems in real time. These facilities would allow direct, long-term study of deep ocean environments that are currently accessible only briefly and at great cost. Together, by advancing technology, expanding infrastructure, and deepening our commitment, we can unlock the mysteries of the deep ocean and protect this vital frontier for generations to come. To learn more, visit us at deepworld.org.